Hello there, and welcome to The Sleepless Scientist. Tonight, we drift into the vastness of interstellar space, where mysteries pass through our solar system like whispers from distant suns. Every so often, an object appears. Alien not in the sense of science fiction, but alien because it does not belong here. It comes from somewhere else, from a star system unimaginably far away, carrying with it a story written in stone, ice, and light. Our theme tonight is 3I Atlas, the third confirmed interstellar object ever discovered, a wanderer that crossed the threshold of our solar system and then slipped away again. We will trace its path, recall its predecessors, and reflect on what such fleeting visitors reveal about the larger galaxy we live in. As always, we'll take our time, moving slowly, letting the details settle like starlight over a quiet ocean. And just before we begin, if these calm, curious explorations help you unwind or give you a quiet way to end your day, consider liking and subscribing to the channel. It helps others find their way here too. One sleepy soul at a time. The unexpected visitor. What is 3I Atlas? At first glance, the story of 3I Atlas begins like any other comet, a faint smudge in the sky, slipping silently among the stars. But as astronomers studied its motion, they realized it was not bound by the sun's gravity. It was moving too fast, on a trajectory that would never circle back. This was not a child of our solar system, it was something else, a true interstellar visitor. The name itself tells the story. The 3I marks it as the third of its kind, following the earlier discoveries of Oumuamua and Comet Borisov. Atlas comes from the telescope system that spotted it, the asteroid terrestrial impact last alert system, and so, in that quiet naming, we hear both science and poetry, an object from another star, found by a watchful eye, turned toward the heavens. What is 3I Atlas? A comet, yes, but also a messenger, a fragment of a place we will never visit, wandering alone through the deep dark until chance brought it near us for a brief, dazzling moment. How astronomers first detected 3I Atlas. Let's go back in time to 2019, when the Atlas Survey telescopes in Hawaii were scanning the night skies, designed to spot potentially dangerous asteroids. These telescopes sweep vast portions of the sky each night, catching even faint glimmers of light moving against the backdrop of stars. On one of these nights, astronomers noticed an object moving oddly, with a path that didn't match the curves of ordinary solar system comets. At first, it seemed like just another icy traveler, but careful measurements revealed something unusual. Its orbit was hyperbolic, open-ended, not closed. That was the giveaway. Hyperbolic trajectories mean the object is not returning. It is passing through, forever unbound. The realization must have been electric. Astronomers around the world turned their instruments toward it, gathering every detail before it grew too faint to study. The moment of discovery is brief, like spotting a stranger walking by and knowing you'll never see them again. Yet in that moment, a universe of questions is born. Why it matters. The third interstellar object ever seen. Think about this. In all of human history, only 3 interstellar objects have been confirmed. Countless comets and asteroids roam our solar system, but true outsiders, those flung from other stars, are vanishingly rare. The first was Oumuamua in 2017, the second Comet Borisov in 2019, and then, years later, 3I Atlas. Why does it matter? Because each one carries secrets. They are physical fragments of other star systems, pieces of worlds beyond our reach, arriving without invitation. With each new discovery, we build a larger picture of how common interstellar wanderers may be. They tell us about the processes of planetary formation, the violence of ejection, and the quiet journeys of matter between stars. The third sighting was crucial. One might dismiss the first as a fluke, the second as coincidence, but 3 begins to feel like a pattern. It suggests the galaxy is filled with such wanderers, and that our solar system is just one way station along their endless road, a cosmic rarity. Why interstellar objects are so elusive? At first glance, it might seem strange that interstellar objects are so rare in our skies, but consider the vastness of space and the tiny window we have through which to watch. These objects are small, often just a few kilometers across, and they move quickly, spending only months, or even weeks within reach of our telescopes. Their rarity is not in their existence, but in our ability to detect them. Imagine raindrops falling into a vast ocean. The drops are countless, but if you stand on the shore, you may only see a few. The same is true of interstellar comets. They are out there, perhaps in great numbers, but only the fortunate ones pass close enough and bright enough for us to notice. This rarity makes each discovery precious, a fleeting chance to study something from beyond our star, something that reminds us that the solar system is not isolated, but part of a larger galactic sea, alive with unseen travelers. Revisiting Oumuamua, the first mysterious visitor. Let's pause and return to the first for context. In 2017, astronomers discovered Oumuamua, an object unlike any ever seen. It was long, cigar-shaped, or perhaps pancake-flat, depending on interpretation. It showed no visible tail like a comet, and yet its trajectory suggested some subtle push, as though gas or dust were escaping invisibly. Oumuamua was strange, not only for its shape, but for the questions it left behind. Was it a comet stripped of its outer layers? A shard of rock from a shattered planet? Or something else entirely? Its name, given in Hawaiian, means a messenger from afar, arriving first, a poetic recognition that this was the beginning of a new chapter in astronomy. By revisiting Oumuamua, we understand why 3-Eye Atlas matters so deeply. Each interstellar visitor carries mystery. Each one reminds us that our solar system is just a stop in a much larger journey. A journey that began around another star, in another time, under skies we will never see. Comet Borisov, the second interstellar messenger. At first glance, Comet Borisov looked like many comets before it. Discovered in 2019 by amateur astronomer Gennady Borisov, it displayed the familiar glow of a coma and the trailing beauty of a tail. But soon, its path revealed a truth far stranger. This was not a comet born in the icy reaches of our solar system. Like Oumuamua before it, Borisov's orbit was hyperbolic, too fast and too wide to be bound by the sun. Borisov was different from Oumuamua in one important way. It behaved like a comet should. It shed dust and gas, creating the ethereal halo that comets are known for. This activity gave scientists their first true chance to study the chemistry of an interstellar object. Spectra revealed water, carbon-based molecules, and other familiar ingredients, confirming that planetary systems far beyond our own make icy bodies much like those in our cosmic backyard. Borisov was the second interstellar messenger. But in its trail of dust, we found something comforting. Though it came from another star, it was not alien in essence. It was familiar, and in that familiarity, it whispered that the processes shaping worlds are universal. How 3-Eye Atlas differs from its predecessors. Here's something intriguing. 3-Eye Atlas is not quite like Oumuamua, and not exactly like Borisov, where Oumuamua appeared rocky and enigmatic, and Borisov icy and active. Atlas seems to blur the line between the two. Astronomers detected faint signs of cometary activity, but it was subtle, not as dramatic as Borisov's. Its brightness fluctuated, as though fragile or unstable, and it disintegrated more quickly than expected. This fragility made 3-Eye Atlas difficult to study. Observers noted that it broke apart as it neared the sun, scattering into fragments too faint to track in detail. In some ways, it was less a single traveler and more a collection of whispers, dissolving as quickly as it appeared. Yet this very difference made it valuable. Atlas revealed that interstellar visitors do not come in just one form. Some are rocky enigmas, some icy wanderers, and others fragile shards. Together, they paint a picture of variety, evidence that other star systems are just as complex, diverse, and unpredictable as our own. Measuring the trajectory of an interstellar wanderer. Think about this. How do astronomers know an object is truly interstellar? The answer lies in its path. Most comets trace ellipses or parabolas around the sun, graceful loops that eventually return them to their starting points. But interstellar objects travel on hyperbolas, curves that open outward, never to close. To measure 3-Eye Atlas, scientists plotted its motion night by night, comparing its speed and arc against the pull of the sun. The numbers revealed the truth. This comet came from beyond, unbound, arriving from interstellar space and destined to leave again. Its velocity was higher than anything our solar system could produce naturally, confirming its alien origin. In studying its trajectory, astronomers also traced its story backward. It came from the outer reaches of the Milky Way, perhaps ejected from a distant star system millions or even billions of years ago. Its path is a signature, a line across the sky that tells of both where it has been and where it is going. The strange speed of 3I Atlas. At first glance, speed is a simple concept, but in the case of 3I Atlas, it carries profound meaning. The comet was traveling at a velocity too great for the sun to hold it. Even at its closest approach, it would not linger. Instead, it whipped around our star and continued outward, back into interstellar space. This speed is not accidental. Interstellar wanderers are flung from their home systems by gravitational slingshots, encounters with giant planets, close passes by stars, or even the violent upheaval of supernovae. The object carries with it the momentum of these ancient events, crossing the gulfs of space with quiet determination. For us, its speed is both a gift and a loss. It confirms its alien origin, but it also limits our ability to study it. We only ever glimpse such objects in passing, like a bird flashing across the sky before vanishing into the trees. Their speed is part of their mystery, a reminder that the galaxy is dynamic, restless, always in motion. Why interstellar paths reveal an alien origin? Here's something subtle yet powerful. The shape of an orbit tells you where an object belongs. Anything bound to the sun must trace a closed path, an ellipse that repeats endlessly. But when astronomers see a hyperbolic path, one that opens outward, they know immediately, this object does not belong here. In the case of 3I Atlas, its eccentricity, the measure of how stretched an orbit is, was greater than 1. That single number is the cosmic signature of an interstellar traveler. Combined with its unusual speed and incoming trajectory, the evidence was undeniable. Atlas came from beyond. These paths are more than geometry. They are stories. They tell of journeys across light years, of ejection from distant nurseries, of the restless scattering of matter throughout the galaxy. Each interstellar path is a thread connecting one star system to another, invisible until we happen to notice it. To read these paths is to glimpse the silent journeys that bind the Milky Way together. Telescopes that made the discovery possible. At first glance, the discovery of 3I Atlas may seem like a stroke of luck, but luck alone is never enough. It was the result of careful design and technology, of telescopes sweeping the sky each night with patient vigilance. The Asteroid Terrestrial Impact Last Alert System, or ATLAS, is not a single telescope, but a pair of robotic eyes located in Hawaii. Their purpose is to search for objects that might someday threaten Earth, scanning vast swaths of sky with a watchful precision. It was during one of these nightly surveys that Atlas found something that was not dangerous, but far more extraordinary. A faint smudge of light that moved too quickly and too strangely to be local. Without Atlas, 3I Atlas would have passed unseen, a ghostly visitor slipping by unnoticed. Instead, technology allowed us to notice, to record, and to wonder. In this way, telescopes do more than gather data. They expand our awareness, bridging the gap between the quiet sky above and the restless cosmos beyond. The role of sky surveys in spotting visitors. Here's something remarkable. Modern astronomy depends not only on single discoveries, but on constant, systematic watching. Sky surveys like ATLAS, Pan-STARRS, and the Catalina Sky Survey quietly map the heavens night after night, creating a record of motion and change. Most of what they find are asteroids, comets, or variable stars. But every so often, among the thousands of ordinary detections, something extraordinary appears. For interstellar objects, these surveys are essential. Their windows of visibility are small, and their movements are swift. Without wide-field surveys, scanning constantly, such visitors would never be seen. The role of these projects is both humble and grand. Humble, because most of the data gathered will never make headlines. Grand, because within that data may lie the rarest of treasures, an object from another star. Sky surveys remind us that patience and repetition are as important in science as sudden breakthroughs. In their quiet persistence, they prepare us to catch the fleeting strangers who pass briefly through our neighborhood of space. The difficulty of tracking fast-moving objects. Think about this. When 3I Atlas was first detected, astronomers had only days to confirm its path before it began to fade. Interstellar objects move quickly, not just across space, but across the field of view. A comet traveling tens of kilometers per second may shift its position noticeably between one night and the next. This speed creates a challenge. To track an object, telescopes must capture it repeatedly, refining the measurements that reveal its orbit. But faintness and motion make this difficult. Sometimes, by the time astronomers turn their instruments to the right spot, the object has already moved on. For 3I Atlas, the difficulty was compounded by its fragility. As it broke apart, it became dimmer, harder to follow, until only fragments remained. In that sense, studying such objects is like trying to hold water in your hands. They slip away, no matter how tightly you grasp. Yet in that slipping, in the act of trying, knowledge still blooms. Why Atlas carries secrets from another star. At first glance, 3I Atlas may look like just another comet, icy and transient, but its true story lies in its origin. It was formed in the disk of another star system, orbiting a sun we will never know. The ingredients within it, the ices, the dust, the rocks, are fossils of a foreign world's formation. They are the fingerprints of a star that shines too faintly or too far for us to see. When Atlas was ejected, it became a traveler, carrying those fingerprints across light years. By studying its light and spectra, we glimpse those alien beginnings. Comparing them to our own comets, are the same molecules present? Are the same ices preserved? Each answer deepens the cosmic mirror, showing us how common or rare our own system might be. In this way, 3I Atlas is more than a comet. It is a capsule of time and place, a messenger of conditions that shaped worlds far beyond our sight, a reminder that the galaxy is both varied and connected. The composition mystery, rock, ice, or both. Here's something that puzzled astronomers. What exactly was 3I Atlas made of? The comet displayed faint signs of activity, jets of gas releasing from its surface, but it also appeared to disintegrate quickly, as though its structure were unusually fragile. Was it mostly ice, loosely held together, or did it carry a mixture of rock and volatile material, making it unstable under the sun's heat? Spectral studies offered some clues, suggesting the presence of carbon-based compounds and water ice, much like comets from our own solar system. Yet the way it broke apart hinted at differences, perhaps in how its material was bound, or how long it had endured in the interstellar dark. This uncertainty is part of the mystery. Rock, ice, or both. It matters less than the story those materials tell. They are the relics of another system's chemistry, frozen and preserved for eons, now dissolving in the warmth of our sun. In that dissolution, they reveal just enough to stir both scientific insight and poetic wonder. Spectral analysis. Reading the colors of alien debris. At first glance, a comet looks like nothing more than a blur of light against the stars. But astronomers have a way of prying into that blur, of asking light itself to reveal its secrets. It is called spectral analysis. By passing the comet's glow through prisms or sensors, they can separate the light into colors, hidden rainbows that carry the fingerprints of atoms and molecules. For 3I Atlas, this meant deciphering what kinds of ices and gases streamed from its fragile surface. Subtle dips and peaks in its spectrum suggested carbon compounds, water vapor, perhaps even traces of cyanide, common in comets closer to home. The question was not only whether the ingredients matched our own, but whether they differed in some quiet, telling way. Every faint spectrum taken of Atlas was like a postcard from another star. The ink faded, the words almost smudged away by distance and time. And yet, within those colors, a kind of message endured. It told us that chemistry, like starlight, is a universal language. How much do we really know about 3I Atlas? Here's something humbling. For all the telescopes turned toward it, for all the data carefully gathered, we know almost nothing about 3I Atlas with certainty. We know its orbit, its speed, the way it brightened and then fractured. We know the hints of its chemical makeup, though those too come wrapped in error bars and doubt. But do we know its birthplace? No. Do we know if it carried hidden minerals, or if its core was solid or hollow? We do not. Much of what we think about Atlas is inference, stitched together from the barest threads of light. Its brief visit left more questions than answers, a reminder of how fleeting knowledge can be when the subject itself is fleeting. Perhaps that is the lesson. Astronomy is not always about grand revelations, but about patient humility, about standing under a sky full of mysteries and learning to accept that sometimes the unknown remains unknown, and in that quiet, wonder grows. Could it be an ejected planetary fragment? Think about this possibility. What if 3I Atlas was not a simple comet, but a fragment of a once larger body, a shard of a planet or moon flung into the void? Such events are not impossible. In young star systems, planets collide, moons shatter, and debris spirals outward. Some of that debris can be thrown free of its home star, cast into interstellar exile. If Atlas were such a fragment, it would carry the hidden story of geological processes we may never witness directly. Its minerals, its density, even the way it fractured could whisper of tectonic upheavals or violent impacts on alien worlds. We may never know for sure, but even imagining this possibility invites us to see Atlas not as a mere visitor, but as an ambassador of planetary history, a small, fragile emissary that reminds us how chaotic and creative the cosmos can be. Interstellar comets, frozen relics of distant suns. Here's something soothing to consider. Interstellar comets, like Atlas, are fossils. They are remnants of star systems long past their youth, relics preserved in the cold of deep space. When a star is born, its surrounding disk is filled with countless icy bodies, drifting far from the warmth of the newborn sun. Most remain, circling silently for billions of years, but some are thrown outward, propelled by planetary encounters or stellar nudges until they escape into interstellar night. Atlas was one such relic. Frozen for untold ages, untouched by warmth, it wandered until chance brought it near our sun. To see it dissolve in our skies is to watch another system's memory melt into vapor. These comets remind us that the galaxy is littered with such fragments, each carrying the story of a different sun. We may never catch them all, but the few that pass remind us of the vast interconnected nature of cosmic history. Why some believe these objects may carry life's ingredients. Let's imagine this. If 3I Atlas carried carbon compounds, water ice, and other organic molecules, then it was not only a relic of its star, but also a capsule of chemistry essential for life. Some scientists wonder whether such objects may scatter life's ingredients across the galaxy, seeding worlds as they travel. It is called panspermia, the idea that life, or at least its building blocks, might hitchhike on rocks and ice between stars. While we have no proof that Atlas carried such treasures, the possibility is tantalizing. A comet fragment falling into a young planet's ocean could deliver amino acids, sugars, or other precursors. From such simple beginnings, complex life might someday arise. Whether or not this happened with Atlas, its visit makes us reflect on the unity of cosmic chemistry. Life as we know it depends on ingredients forged in stars, scattered in dust, carried in comets. Perhaps the galaxy itself has always been a gardener, planting seeds in every corner of the night. Panspermia. Could life ride on interstellar rocks? At first glance, the idea sounds like science fiction. Life, drifting between stars on the back of a comet. Yet panspermia is a theory scientists take seriously because the chemistry of life is surprisingly robust. Bacterial spores can endure freezing temperatures, radiation, and the vacuum of space for long stretches of time. Organic molecules can survive deep within rocky shells, shielded from harsh sunlight. If 3I Atlas carried such ingredients, then it becomes not just a relic of its home system, but a possible courier. Imagine fragments breaking free and falling into the seas of a young world. There, Amid warmth and minerals, the seeds might awaken into something more. Of course, there is no evidence that life actually travels this way. It may be only a dream, a reminder of how eager we are to connect ourselves with the wider galaxy. But even as speculation, it reframes comets like Atlas as more than icy wanderers. They become symbols of possibility, carriers of hope that life might not be confined to a single fragile planet. The scale of the journey, trillions of miles traveled. Here's something almost impossible to picture. By the time 3I Atlas entered our solar system, it had already traveled trillions of miles through the dark. To measure its journey is to measure patience itself. Millions of years, perhaps billions, slipping between stars with no destination. A single grain of dust, carried by currents we cannot see. The numbers overwhelm us. A light year itself is nearly 6 trillion miles. How many of those did Atlas endure? Was it ejected only recently, from a star not too far away? Or has it been adrift since before the Earth had oceans, older than the continents beneath our feet? Distance turns into time, and time turns into awe. The comet's brief appearance in our skies was the end of a journey longer than human history can grasp. For a few short weeks, we glimpsed the trail of an ancient traveler, and then it was gone again, resuming its endless voyage. Cosmic slingshots, how stars eject wanderers. Think about this. Atlas did not choose to leave its home star. It was cast out, somewhere long ago. Gravitational forces flung it free. Perhaps a giant planet tugged it too strongly during a close encounter, giving it a boost of energy beyond escape velocity. Perhaps a passing star brushed the system, disturbing orbits like marbles scattered across a floor. Such slingshots happen often in young systems, where planets and debris are still settling into their places. In our own solar system, Jupiter has acted as a great slinger of comets, pulling some inward, hurling others outward into the void. It is the quiet violence of gravity, reshaping the architecture of worlds. 3I Atlas was a product of this process, a shard of ice and dust, carried away like a forgotten child into the deep night. And though we cannot trace the exact hand that cast it out, we know the forces. They are the same ones that shaped our own world. Why our solar system is just a stop on its journey. For all the excitement it caused, Atlas did not belong to us. Our solar system was never its home, only a brief waypoint on an endless path, like a traveler pausing at a roadside inn. It arrived suddenly, stayed for only a moment, and then departed again into the dark. This reminds us of our own smallness. We often imagine the solar system as the center of things, yet to Atlas it was just another bend in the road. Countless such systems exist across the galaxy, and Atlas may pass through many more before it is gone. Its indifference is humbling. The comet did not come for us, and it will not remain. And yet, in noticing it, we gave it meaning. We marked its presence in our history, even if to the universe it was just a shadow flickering by. The challenge of studying brief visitors. Here's something to reflect on. The greatest difficulty in studying interstellar visitors is time. They move quickly, fade quickly, and offer us only the thinnest window to gather information. Astronomers scramble when such objects are found, coordinating telescopes across continents and wavelengths. Every night matters. Every observation adds another piece to the puzzle. With 3I Atlas, the challenge was even sharper because of its fragility. It broke apart just as scientists were beginning to measure it. Whole pieces of evidence vanished into dust, leaving only faint traces for us to interpret. This fleetingness is frustrating, but also strangely beautiful. It forces us to appreciate each moment of clarity. Each data point is a gift, each spectrum a miracle of timing. Studying such objects teaches us not just about the cosmos, but about impermanence, the way wonders appear and fade before we are ready to let them go. The short window before 3I Atlas fades away. At first glance, it might seem surprising how quickly 3I Atlas slipped from view, but interstellar visitors like this are fleeting by nature. They arrive suddenly, brighten as they near the sun, and then retreat, fading into invisibility. The window to observe them is measured not in years, but in weeks. For Atlas, The urgency was heightened by its fragility. Its nucleus, likely a loose collection of dust and ice, began to break apart under the sun's warmth. What had first appeared as a single compact traveler soon fractured into ghostly fragments. The brighter glow dispersed, and the target astronomers had pointed toward blurred and weakened. This short window taught us a lesson about the limits of our reach. No matter how sophisticated our instruments, they cannot lengthen time itself. We can only watch while the moment lasts, knowing that the comet will slip away into the night once more. In that sense, Atlas was not unlike a dream, vivid while present, then gone, leaving behind only memory and wonder. Why we cannot send a probe to study it up close. Think about this. The very moment an interstellar comet is discovered, it is already too late to send a spacecraft. Our technology is simply not yet fast enough, nor ready enough, to respond to such fleeting arrivals. Missions require years of planning, engineering, and launch windows carefully aligned with planetary positions. By the time such a mission could be prepared, the visitor is long gone. With Atlas, the problem was even sharper. It moved at tremendous speed, far beyond the reach of any rocket humanity has yet built. To catch it would require not just readiness, but propulsion systems capable of chasing down an object, moving tens of kilometers per second. Even our fastest spacecraft, like the Voyager probes or New Horizons, could not match such pace. It is frustrating to watch an interstellar messenger pass so near, knowing we cannot meet it. But perhaps that frustration plants the seeds for the future. For one day, we may be ready, dreams of future interstellar interceptors. Here's something hopeful. Though we cannot yet chase interstellar visitors, scientists are already imagining ways we might. Concepts like the interstellar probe or the Comet Interceptor mission envision spacecraft that wait in readiness, stationed far from Earth, fueled and poised to spring into action when the next visitor arrives. These interceptors would not be built for a specific target, but for flexibility. The idea is simple. Keep the craft dormant, then awaken it when surveys spot a new interstellar traveler. With rapid maneuvers, it could meet the visitor on its path, taking close images, sampling dust, and perhaps even flying through its coma of gas and particles. Such dreams remain in early planning, but the vision is clear. The galaxy will send us more of these messengers. Each one is a fleeting gift, and we are determined not to let the next pass by unstudied. The future of astronomy may depend as much on readiness as on discovery. Could we ever catch an interstellar object? At first glance, the idea sounds impossible. How could we catch something moving faster than any human-made craft has ever gone? Yet scientists believe it may not be beyond reach. Advances in propulsion, whether nuclear-powered rockets, solar sails pushed by light, or even experimental ion drives, could someday allow us to match speed with an interstellar traveler. The key would be anticipation. If we can detect such an object early enough, before it nears the sun, we gain precious months or years to prepare. With early warning, an intercept mission could launch in time to meet it. Even then, the encounter would be brief, but close enough to study its structure directly. Will we ever catch one? Perhaps not in the near future, but the very fact that we ask the question shows how far our imagination stretches. What today feels like a dream may, in time, become a milestone. The cosmos invites us to chase, and one day, perhaps, we will. Why each visitor expands our cosmic perspective. Here's something to ponder. Even if we never intercept one directly, every interstellar object we glimpse broadens our understanding. With each fleeting visitor, we are reminded that the galaxy is not a set of distant stars, but a connected web, sharing fragments and wanderers. Atlas, like Oumuamua and Borisov before it, carried whispers from another sun. These visitors expand our sense of place. They show us that the materials of planets and comets are not confined, but scattered across light years. They suggest that our solar system is not unique, but part of a larger story of birth, collision, and ejection. Each object widens the stage upon which we imagine life, planets and stars. The perspective they offer is humbling. They remind us that our neighborhood is small, that countless others exist, and that between them flow endless streams of dust and stone. Every visitor is not just an object of study, it is a lesson in humility, an invitation to see the galaxy as whole. the story written in orbits and arcs. At first glance, the faint arc traced by 3i Atlas across the sky seems simple, almost unremarkable, just another streak of motion. One star crossing among thousands catalogued each night. But within that curve lies a story. An orbit is not only a path, it is a confession. It reveals speed, direction, and origin, encoded in mathematics as old as Newton, yet pointing to mysteries as wide as the galaxy itself. When astronomers plotted Atlas's course, they saw immediately that it was not bound to our sun. Its trajectory was hyperbolic, a shape that does not close upon itself but opens outward, as though the object were passing through rather than circling back. This single clue announced what it was. Not local, but interstellar. To trace an orbit is to listen to the whispers of gravity, to reconstruct the silent forces that set a body in motion. In Atlas's arc, we see echoes of its past and predictions of its future. It reminds us that even the most fleeting visitor leaves behind a line of truth written in the sky. Why 3i Atlas may be more common than we think. Here's something surprising. Though we have only detected 3 interstellar objects so far, astronomers now suspect that such wanderers may be far more common than our limited instruments suggest. Each discovery, Oumuamua in 2017, Borisov in 2019, and Atlas in 2020, arrived within only a few short years of one another. That frequency hints at abundance. Imagine countless comets and fragments drifting unseen between the stars, slipping silently past our solar system in numbers too great to tally. Most are too faint, too distant, too swift for us to notice. But if 3 have appeared so quickly in our surveys, how many more have passed unnoticed in centuries before? The thought reframes the galaxy, not as static, but as restless. Worlds are constantly trading fragments, scattering material that travels across light years. The Milky Way may be full of such messengers, their stories invisible until we learn to see them. Perhaps Atlas was not rare at all, but only the first of many we will one day greet. Interstellar objects as evidence of galactic migration. Think about this. Every interstellar comet is evidence of motion, not just within star systems, but across the galaxy itself. When a star wanders through the Milky Way, its gravity can disturb its own outer reaches, flinging icy debris into interstellar space. Over time, these ejected bodies become the drifters we occasionally glimpse. 3i Atlas was part of this greater migration. It may have been ejected from its birth system by a planet's tug, but its larger journey is tied to galactic movement. Stars orbit the center of the Milky Way, weaving through spiral arms, pulling their fragments with them. An interstellar object is not simply a refugee from one world. It is a participant in a dance that spans the galaxy, a small stone carried in a tide older than Earth itself. When we study Atlas, we are not just studying a comet. We are watching the faint ripple of galactic dynamics, a reminder that even dust participates in the grandeur of cosmic motion. What these visitors reveal about other star systems. At first glance, a fragment of ice may not seem like much of a messenger, and yet these visitors carry within them the raw material of their birthplaces. By comparing their spectra with comets in our own solar system, astronomers can glimpse the chemical diversity of other suns. Are the ratios of water to carbon dioxide the same? Do they contain familiar organics or rare compounds absent from our skies? In 3i Atlas, the hints lean towards similarity. It behaved in many ways like our own comets. Fragile, volatile, easily torn apart by sunlight. That resemblance is itself a revelation. It suggests that the processes shaping icy bodies may be universal, that distant suns form comets much as ours did, and yet subtle differences linger. The way Atlas fragmented, the faint traces of its chemistry, may hint at variations in its home system. Each detail becomes a clue, a puzzle piece in the vast mosaic of galactic diversity. Through these messengers, we see reflections of worlds we cannot yet visit, the ancient past encoded in alien ice. Here's something poetic to hold on to. Inside the fragile ice of Atlas lies memory. Comets are among the most ancient objects in any star system, formed from the leftovers of creation itself. Their ices preserve the conditions of their birth, unchanged for billions of years in the cold. To glimpse Atlas, then, was to look into a time capsule, Its atoms and molecules were assembled when its star was young, perhaps even before planets formed around it. They carry whispers of temperature, pressure, and chemistry from an age we cannot otherwise touch. Though Atlas broke apart, though it faded too soon, what little we saw was enough to remind us of this truth. Ice is a storyteller. In its fragile crystals are locked the beginnings of worlds. And when a comet from another system drifts into ours, those beginnings cross the gulf of space to meet us, briefly, before dissolving into light. How long 3I Atlas has been traveling alone? At first glance, 3I Atlas appears as a fleeting streak in our sky, but in reality, it has been journeying alone for eons. Imagine the time it took to traverse the gulf between its home star and our sun. Millions, perhaps billions of years. Through that immense span, it drifted in the cold darkness of interstellar space, untouched by warmth, unlit by anything other than distant starlight. This lonely voyage shaped its fragile structure. Without frequent encounters, its ice remained frozen, and its dust settled undisturbed. It preserved a record of conditions far from any sun. Yet solitude comes with peril. Collisions with stray micrometeorites, cosmic radiation, and gravitational nudges may have slowly eroded its surface. Still, it endured, arriving in our system as a survivor of time itself. Contemplating its journey forces us to stretch our imagination. We are accustomed to lifespans measured in decades or centuries. Atlas challenges us to think in millions of years, to imagine a lonely traveler that predates human history and yet intersects with our own brief existence in a fleeting moment. Cosmic loneliness of interstellar wanderers. Here's something quietly profound. Objects like 3I Atlas experience a solitude unlike anything on Earth. Bound to no star, tethered to no system, they wander endlessly through the void. Their paths are dictated only by gravity, by chance encounters with other stars or interstellar gas clouds, and by forces invisible to us. This loneliness is not melancholic. It is simply the nature of interstellar life, if such objects can be said to live. In the emptiness, Atlas has no companions, no echoes of its origin nearby, only the occasional brush with radiation or dust. For billions of years, it has known only itself and the silence of space. Yet in this cosmic solitude, there is poetry. Its brief passage through our system reminds us of the fleeting connections possible, even across unimaginable distances. We, for a moment, intersect with its journey, and in that crossing, its isolation gains meaning. Why they may outlast entire stars. Think about this. Stars have lifetimes, finite spans of fusion and fire, but small bodies like 3I Atlas, traveling between the stars, can endure far longer than the very suns that birthed them. Ice, dust, and rock are resilient. Without the heat and pressure that ages a star, these fragments may persist long after their parent star has dimmed or died. Atlas is a relic, a ghost of its system, carrying its story far beyond the lifespan of the star that formed it. It reminds us that the cosmos preserves memory in many forms, not only in blazing suns, but in the quiet endurance of tiny wanderers. Each object is a testament to time, outlasting the fiery hearts of worlds around which it once orbited. In this way, interstellar objects become living archives, carrying the echoes of creation far longer than the stars themselves. The galaxy is not just a stage for bright, fleeting brilliance. It is a repository of subtle, enduring histories. How collisions eject rocks into interstellar space. Here's something fascinating. The journey of Atlas began with violence. Collisions are one of the primary ways small bodies are cast from their home systems. Young planets collide with leftover debris, moons strike worlds, giant planets scatter fragments through gravitational encounters. Each impact sends material flying, some on trajectories that exceed escape velocity, leaving their stars behind. These collisions are common in planetary systems, a natural consequence of formation. While destructive, they are also creative, distributing matter and energy across the galaxy. Some fragments fall back into orbit, forming moons or new asteroids, while others, like Atlas, are ejected into the interstellar void. In that way, every interstellar visitor carries evidence of past cataclysms. They are survivors of chaos, records of processes too violent to witness directly. Their mere existence is proof that cosmic upheaval is not the exception, but an integral part of how planets and systems evolve. Supernovae and stellar explosions as cosmic catapults. At first glance, supernovae seem destructive, ending stars with a sudden blinding explosion. But in the broader cosmos, they can also act as launchers of matter, sending debris hurtling into interstellar space. A comet or asteroid caught in the gravitational turbulence or shockwave of such an event can gain enough velocity to escape its system entirely, beginning a journey like that of Atlas. These events are rare and dramatic, yet they highlight how interconnected stellar lives are with the fates of small objects. Atlas may have been ejected gently by a planetary encounter or violently by a stellar explosion. Either way, its journey through the galaxy is a product of forces both subtle and immense, of chance and inevitability combined. In watching Atlas pass through our skies, we witness the aftermath of events that occurred far beyond our reach and long before humans existed. Its trajectory is not random. It is written by the grand mechanics of the universe, by collisions and explosions that ripple across light years. Why 3I Atlas might carry clues of stellar deaths. At first glance, Atlas may seem like a mere comet, fragile and fleeting, yet it may hold within it the echoes of violent stellar deaths. Supernovae and other cataclysmic events in its home system could have altered its composition, embedding rare elements or shock-altered minerals. Its ice and dust may carry subtle evidence of nuclear reactions that occurred before it was even ejected. These clues are hidden in the faint colors of its spectrum, in the ratios of carbon, nitrogen, and oxygen, and in the trace metals that survive the ejection into interstellar space. Each measurement is like reading a letter written billions of years ago, describing processes we cannot witness directly. In this way, Atlas is more than a traveler. It is a messenger from a star long gone, or a system transformed by cosmic violence, offering glimpses of creation and destruction intertwined. Observing it allows us to study the aftershocks of stellar life cycles, carried silently across the void. What we can learn about planetary formation. Here's something quietly profound. 3I Atlas offers a window into how planets and smaller bodies form around distant suns. Its composition, structure, and trajectory all carry hints of the processes that shaped its home system. Ice, rock, and dust ratios suggest where it originated within the system, close to the star, or in the colder outer reaches. By comparing Atlas to comets and asteroids in our solar system, scientists can infer universal patterns. Are water and carbon compounds common? Are volatile ices preserved in similar ways across the galaxy? Each data point adds to our understanding of planetary formation on a cosmic scale beyond the confines of our own sun. Even its fragility is instructive. The way it broke apart under solar heat suggests limits on structural integrity in small bodies, informing models of how comets, asteroids, and protoplanetary debris evolve over time. In short, Atlas is a natural laboratory, one we encounter only briefly, yet one capable of teaching lessons billions of years old, a messenger from a sun we'll never see. Think about this. Atlas is a traveler from a star we may never identify. Its origin could be thousands of light years away, in a system so distant that even our most powerful telescopes cannot glimpse it. Yet in a single moment, it passed through our neighborhood, delivering materials, energy, and information from that unreachable world. It is a reminder that the galaxy is alive with connections invisible to us. A comet is not simply ice and rock. It is a letter, a whisper, a story from a star whose light may never reach our eyes directly. And yet, by capturing its light and analyzing its fragments, we can read that story, tracing lines across the cosmos that link one system to another. Atlas teaches us humility, showing that much of the universe remains unseen. Still, even fleetingly, it offers a bridge between our small, sun-centered perspective and the vast, interconnected galaxy beyond. The speed limits of interstellar travel explained. Here's a subtle, almost meditative point. The velocity of Atlas is not arbitrary. Interstellar objects are bound by the gravitational landscapes they traverse. To escape a star's pull, a comet must reach a speed exceeding the escape velocity, often aided by planetary slingshots or stellar perturbations. Its hyperbolic path ensures it will not return, forever free to drift between suns. Speed also dictates what we can learn from such objects. Fast-moving travelers give us only brief observational windows. Their trajectories limit close study, and make it nearly impossible to send a spacecraft in pursuit. Yet the very speed that frustrates us is also the signature that reveals their alien origin, differentiating them from comets born within our own solar system. In watching Atlas streak across the sky, we are witnessing the delicate balance of forces that allowed it to leave one system and journey to another, a testament to the quiet power of gravity and chance. Why its path confirms an alien origin. At first glance, Atlas might appear as just another comet, brightening as it approaches the sun, but its path tells a different story. Its hyperbolic trajectory, with eccentricity greater than 1, marks it as unbound to our sun. Its velocity exceeds what could be produced by the gravitational pull of our solar system alone. This simple fact, written in numbers and angles, confirms its interstellar origin. Its motion is a declaration. It does not belong here, it never has, and it will continue onward, free from our system's grasp. By tracing this path, astronomers can reconstruct not only its recent approach, but also glimpse its ejection from a distant system. In that hyperbolic arc, we see both evidence and poetry. The comet is a wanderer, a traveler crossing the silent void, and yet its brief visit brings it into our awareness, reminding us that the galaxy is full of travelers we may never meet again, each carrying the story of a star we may never see. The difference between bound and unbound objects. At first glance, comets may all appear similar, streaking across the sky in luminous arcs. Yet there is a fundamental difference between those bound to our sun and those that are unbound. Bound objects follow elliptical orbits, returning periodically to familiar paths, their movements constrained by gravity. Unbound objects, like 3i Atlas, trace hyperbolic trajectories, never to return, liberated from any single star's dominion. This distinction is more than a technicality. It tells us about the comet's origin, about the forces that shaped its journey, and about the broader dynamics of the galaxy. An unbound comet has been cast adrift, either by a planetary encounter or a stellar nudge, and in its path we see a story of escape and exploration. Bound comets, in contrast, remain intimate with their home star, repeating ancient cycles. By studying both types, astronomers can discern patterns of formation, ejection, and survival. Bound objects whisper of local histories, while unbound wanderers carry tales from distant suns. In Atlas we hear a voice, not of our neighborhood, but of the broader galaxy. Why gravity cannot hold 3i Atlas here? Think about this. Gravity binds planets, moons, and comets to their stars, yet it is not universal in its embrace. Atlas's velocity exceeds the sun's escape velocity, and no amount of orbital tug or solar pull can halt its passage. It is free, a true interstellar traveler, indifferent to our gravitational dominion. This liberation is what allows astronomers to identify it as alien. The laws of motion and gravity, laid down by Newton and refined by centuries of observation, let us reconstruct its path and confirm its hyperbolic trajectory. Unlike the familiar comets of our solar system, Atlas will never orbit the sun again. In that freedom lies a quiet lesson. The universe is vast, and even seemingly insignificant objects obey rules that place them beyond our reach. Gravity is both a tether and a release, depending on circumstances. For Atlas, it was the latter, a reminder that the cosmos contains journeys far larger and more complex than human intuition can easily grasp. The open question, how many are passing undetected? Here's something thought-provoking. For every interstellar object we detect, there may be thousands that pass unnoticed. Our telescopes are powerful, but their coverage is limited. Many objects are too faint, too small, or simply appear in the wrong part of the sky at the wrong time. This raises a humbling question. How many cosmic messengers have drifted past us, unseen, carrying clues about other star systems? If Atlas, Oumuamua, and Borisov are any indication, the galaxy may be teeming with wanderers, silently bridging worlds with their frozen trails. The potential abundance of interstellar objects challenges our perception of the solar system as isolated. Instead, we inhabit a busy cosmic neighborhood where material is constantly exchanged, and the stories of countless stars might sweep past unnoticed. Our glimpse of Atlas is, in a sense, a rare window into an otherwise invisible traffic of alien relics. Are we missing thousands of interstellar visitors? Think about this. With current technology, the odds are stacked against detection. Many objects are small, dim, or fast-moving, slipping by like ghosts in the night. Our surveys cover only portions of the sky at any given time, meaning that interstellar comets could pass undetected for decades, centuries, or even millennia. The realization is both sobering and exhilarating. Sobering because we know so little about the galaxy's inventory of wandering bodies. Exhilarating because it suggests that every year may bring new discoveries, surprises waiting just beyond our field of vision. Every survey, every new telescope, increases the chance of capturing another fleeting visitor. Atlas was not the first, and it will not be the last. Each detection teaches us not just about that single object, but about the broader population, helping to refine models of interstellar object frequency and origin. The unseen majority reminds us of the vastness and richness of our galaxy, most of which we have yet to explore. The future of all sky surveys. Here's something hopeful. Upcoming surveys promise to change everything. Projects like the Vera Rubin Observatory and other next-generation telescopes will scan the entire sky with unprecedented depth and speed. Their sensitivity and coverage will allow astronomers to detect smaller, fainter, and faster-moving objects, potentially thousands of new interstellar visitors each year. These surveys will not merely expand our catalog, they will open a new era of understanding, providing data to study compositions, trajectories, and origins with precision previously unimaginable. The fleeting nature of Atlas may be less a limitation in the future, as technology allows us to react more quickly, to track, and perhaps even intercept new visitors. In that sense, Atlas is a herald. Its brief passage is a reminder of what exists beyond, and the surveys of tomorrow promise to illuminate countless others. Each new object will bring fresh insights, expanding both our scientific knowledge and our poetic appreciation of the galaxy. New eyes on the sky. Vera Rubin Observatory. At first glance, a telescope may seem like nothing more than glass and metal, yet it is a portal, a way to perceive the universe beyond what our eyes can see. The Vera Rubin Observatory, set to survey the entire sky with unprecedented sensitivity, promises to become one of our most vigilant sentinels. It will watch for fast-moving, faint objects that might otherwise escape notice. For interstellar travelers like 3i Atlas, such observatories could make all the difference. Instead of relying on chance, astronomers will have near-continuous surveillance of the skies. Comets and asteroids, previously invisible until nearly gone, will be tracked earlier and more accurately, giving us the rare opportunity to study them in real time. The Rubin Observatory represents more than technology, it represents patience and persistence. By scanning billions of stars and galaxies night after night, it will unveil a hidden stream of cosmic messengers, each one carrying whispers from distant systems. In its gaze, the fleeting becomes visible, and the galaxy begins to reveal its secrets. Why the next interstellar visitor might be spotted sooner. Here's something remarkable to consider. With better surveys and faster detection systems, the next interstellar visitor may not surprise us. The gap between discovery and study could shrink from weeks to days, or even hours. This means that astronomers could collect far more information than ever before, observing chemical signatures, monitoring fragmentation, and calculating trajectories with far greater precision. Early detection would change the story of interstellar objects. Instead of fleeting glimpses, we could conduct detailed studies, watch interactions with the sun, and anticipate how these travelers evolve under solar radiation. Each new detection would be a small miracle of timing, coordination, and technology, expanding our understanding of interstellar processes. And yet, no matter how early we spot them, their journeys remain vast, their origins distant, and their mysteries profound. Each arrival is still a brief intersection of human curiosity and cosmic drift, a reminder of how fleeting and precious such encounters are. Could we ever predict interstellar arrivals? Think about this. Could we anticipate a comet like 3i Atlas before it enters the solar system? In principle, yes, but in practice, it is extraordinarily difficult. Interstellar objects arrive from any direction, moving at speeds unlike most local bodies. Predicting their appearance requires a combination of luck, continuous monitoring, and extraordinary computational power. Future technology may allow earlier recognition of potential visitors, perhaps even months or years before close approach. Simulations of galactic dynamics could suggest likely ejection paths from nearby stars, giving astronomers hints about where to look. Yet each object retains an element of unpredictability, a cosmic spontaneity that ensures discovery will always carry the thrill of surprise. In attempting prediction, we confront both the limits of knowledge and the poetry of chance. Interstellar arrivals are part science, part serendipity, a dance between human ingenuity and the indifferent motions of the galaxy. The mystery of interstellar chemistry. At first glance, a comet is ice and dust, but its chemical signature is far more intricate. Interstellar comets like 3I Atlas are laboratories of alien chemistry, frozen relics preserving the raw materials of distant planetary systems. Spectral analysis can reveal water, carbon compounds, metals, and perhaps even more complex organic molecules. The variations among these chemicals tell a story of stellar formation, planetary processes, and cosmic evolution. Are these compounds identical to those found in our solar system, or do they suggest novel processes at work elsewhere? Each spectral line is a question, each absorption feature a hint of environments we cannot visit. In this sense, Atlas is a teacher. Its chemistry reveals that other stars may form planets and comets in ways both familiar and strange. Even in its brief passage, it offers a laboratory for understanding the universe's diversity, hinting at the universality and variability of the elements that build worlds. Comparing alien ices to solar system ices. Here's something quietly amazing. By comparing 3I Atlas's ices to those in our own system, we begin to measure how similar, or different, other star systems may be. Ices preserve conditions of formation, temperature, pressure, radiation exposure, allowing astronomers to reconstruct the history of a distant system from a fragment of rock and frozen water. In Atlas, the proportions of water, carbon monoxide, and other volatiles hinted at processes both familiar and alien. Some ratios mirrored what we see in comets here, suggesting universal chemistry. Others were subtly different, a whisper that its home star may have had a unique environment. Such comparisons remind us that the galaxy is a laboratory with infinite experiments. Every interstellar visitor is a frozen data point, a small fragment carrying evidence of distant suns. By studying these fragments, we expand our understanding not only of chemistry, but of the cosmic conditions that might allow life to arise elsewhere. Why 3I Atlas might look familiar, yet be entirely different. At first glance, 3I Atlas might resemble comets we know, glimmering in the night sky, trailing dust and gas in delicate streams. And yet, closer observation reveals subtle differences. Its structure, composition, and behavior may not perfectly mirror any object in our solar system, suggesting that while some cosmic rules are universal, others vary with local conditions. This duality is both comforting and disorienting. The familiar aspects give us confidence that we understand some of the physics at play. Sublimation of ice, formation of dust tails, responses to sunlight. But the differences remind us that each star system is its own experiment. Each comet a unique participant in a galaxy of variation. In observing Atlas, we are simultaneously at home and abroad. We recognize the patterns we know, yet we are reminded of the vast unknown that still surrounds us. Even in apparent familiarity, there is mystery, waiting to be teased out of the faint light it reflects. The importance of studying dust and tails. Here's something quietly profound. The tail of a comet is more than decoration. It is a record. As sunlight warms 3I Atlas, ice sublimates and dust is released, forming the visible tail we see from Earth. This tail carries clues about composition, particle size, and the forces acting upon the object. Dust and gas are messengers. Their behavior reveals the interaction between the comet and the sun's radiation, between structure and erosion. By studying the tail, astronomers can infer internal composition, fragmentation patterns, and even history of heating. Tiny grains may tell us about chemical environments billions of miles from their origin, while streams of gas reveal the processes that shaped the comet long before it reached our solar system. The ephemeral beauty of the tail is matched by its scientific significance. In those luminous strands, the comet writes its history, leaving a trail that tells a story we can decipher if only we pay careful attention. The role of solar radiation in shaping its path. Think about this. Sunlight is more than illumination. For a fragile interstellar traveler, solar radiation exerts pressure, subtly pushing it, altering its trajectory. Even the smallest force, acting over millions of miles, can change the course of a comet. Atlas, passing close to the Sun, experienced this pressure. Ice sublimated from its surface, releasing jets of gas and dust that created tiny, reactive nudges. These forces, though minor in human terms, can influence calculations of speed and trajectory. In essence, the Sun both reveals and reshapes the visitor, affecting its final exit from our system. This interaction is a dance of energy. Radiation illuminates Atlas, transforms its structure, and guides its passage, connecting the visitor to our Sun in subtle, invisible ways. Even a brief encounter with our star leaves lasting traces on a journey that has spanned eons. How sunlight alters interstellar travelers. Here's something delicate to imagine. Sunlight does more than heat. It chemically modifies the surface of a comet, slowly breaking down molecules, exposing new layers, and triggering reactions invisible to the naked eye. Atlas, traveling at tremendous speed, experienced intense radiation over its brief solar passage, altering its composition in ways that may persist for millennia. These alterations are significant for scientific study. They can mask the original chemistry of the comet, complicating analysis, yet they also provide insight into the physics of small bodies in extreme environments. The way the ice and dust respond to sunlight reveals strength, structure, and resilience, painting a portrait of a traveler hardened by both distance and exposure. In that sense, every interstellar visitor is a storyteller, shaped not just by origin, cosmic weathering over eons of travel. At first glance, a comet seems timeless, a frozen relic from another world. Yet over eons, interstellar travel slowly sculpts and erodes these objects. Cosmic rays bombard them, micrometeoroids chip away surfaces, and radiation subtly alters chemical bonds. The icy matrix of 3I Atlas has endured processes that are invisible, silent, and relentless. This weathering is a record, a subtle chronicle of the journey. Cracks, fractures, and compositional changes speak of the aeons it spent in isolation, drifting past stars, through voids, untouched by warmth until it approached our Sun. Each scratch and sublimation feature is a footprint of cosmic time. By studying such weathering, we gain insight into the longevity of interstellar objects and the environments they traverse. Atlas is a survivor, carrying within it the echoes of millions of years of space, a testament to endurance in the quiet, boundless dark. Could 3I Atlas have passed near other civilizations? At first glance, the idea seems fantastical. A small comet, drifting through the void, passing near worlds inhabited by intelligent life. Yet the galaxy is vast, and 3I Atlas has traveled for millions, perhaps billions of years. Its path may have brought it through countless planetary systems, some with the potential for life as we understand it. Consider the possibilities. Any civilization along its path would likely have perceived it as a faint, fleeting object, a minor visitor illuminated by their own sun. It is improbable that it left direct evidence, yet the thought remains poetic. Atlas is a traveler, bridging cosmic distances, carrying material forged in alien environments, connecting worlds it may never see. In this way, interstellar objects remind us that even silent, non-living matter can serve as a messenger. Across the galaxy, they weave connections, subtle and unnoticed, between stars, planets, and potentially life itself. They are both lonely and communal, moving alone, yet bridging the cosmos. Interstellar visitors as carriers of ancient stories. Think about this. Every interstellar comet is a storyteller. Embedded in its ice, dust, and rock are the conditions of its birth, the collisions that shaped it, and the chemical processes that occurred over eons. 3I Atlas, like its predecessors, carries tales from a system light years away, whispers preserved in a frozen time capsule. When astronomers study its spectrum, they are decoding these ancient stories. Every molecular signature, every trace element, offers insight into distant suns and planets we may never see. In that sense, interstellar objects are cosmic historians, delivering information that predates humanity by billions of years, yet arriving at our doorstep with uncanny timing. Their stories remind us that the galaxy is not only a collection of stars and planets, but a repository of memory. Atlas connects the past and present, distant systems, and our own, illuminating the unseen threads of cosmic history.
Why some theories link Oumuamua to technology.
Here's something that stirred the imagination of both scientists and the public. Oumuamua, the first interstellar object discovered, exhibited unusual acceleration and an elongated shape, sparking speculation about artificial origins. While mainstream science favors natural explanations, such as outgassing or fracturing, the debate highlights our fascination with the unknown. And the 3I Atlas invites similar, if quieter, speculation. Its hyperbolic trajectory and unique characteristics provoke reflection about what might exist beyond our understanding. While there is no evidence suggesting technological origin, the mere possibility fuels curiosity and reminds us of the limits of knowledge. Speculation, when tempered by scientific rigor, becomes a way to expand thinking. It encourages exploration, fosters creativity, and underscores the profound mystery of interstellar objects. Atlas, in this way, teaches us not only about matter and motion, but about imagination and humility. Could 3I Atlas inspire similar speculation? At first glance, Atlas appears more conventional than Oumuamua, yet it still captivates the mind. Its journey, chemistry, and brief visibility spark questions. Could there be unknown processes at play? Might it carry signatures of extreme cosmic events, or even traces of chemical pre-life from distant systems? While speculation must be cautious, it plays a role in science. By imagining possibilities, researchers ask the questions that guide observations and theory. Atlas, like every interstellar visitor, serves as a spark, prompting us to consider what is plausible, what is extraordinary, and what remains beyond the reach of current understanding. Its passage is a reminder that the universe is full of surprises. Even objects that appear ordinary may challenge assumptions and inspire wonder, connecting rigorous study with the poetic sense of discovery that has always driven humanity's gaze toward the stars, separating science from science fiction. Think about this. The boundary between science and imagination is delicate when it comes to interstellar visitors. 3. Atlas offers genuine scientific insight, yet its brief appearance and alien origin naturally invite fantastical interpretations. The task of astronomers is to remain grounded in data, measurements, and analysis, while allowing room for curiosity. Spectroscopy, trajectory calculation, and thermal modeling provide concrete knowledge about composition, motion, and behavior. Speculation can inspire new lines of inquiry, but must always be tested against observation. By separating imagination from empirical study, we honor both the rigor of science and the wonder of the universe. In the end, Atlas exists in the intersection of knowledge and mystery. It is real, tangible, and measurable, yet it reminds us that much remains unknown. Science and imagination coexist here, guiding humanity toward understanding while preserving the magic of the cosmic unknown. What we can say with certainty about 3I Atlas. At first glance, the universe seems to whisper secrets in every corner. Yet with Atlas, there are truths we can hold firmly. We know it is interstellar, traveling on a hyperbolic path that proves it does not belong to our sun. We know it is composed of ice, dust, and rock, fragile enough to fragment as it nears the sun. Its trajectory and speed are measurable, predictable, and real, forming a foundation of certainty amid cosmic ambiguity. These certainties anchor our understanding. They remind us that even with fleeting observation, science can extract meaning from brief encounters. In the patterns of light, in the traces of its tail, and in its carefully charted motion, Atlas speaks clearly about its nature. While we may not yet know its full chemical story or distant origin, these core facts are indisputable. By embracing what we know, we create a base from which curiosity can safely reach further, exploring possibilities while respecting the limits of evidence. The humility of studying fleeting visitors. Here's something quietly profound. Studying interstellar objects teaches humility. Atlas appeared suddenly, moved quickly, and faded just as rapidly. No matter the precision of our instruments or the skill of our astronomers, its visit was brief, a reminder that the universe operates on scales far larger and faster than human attention can comfortably follow. Humility is not resignation, it is recognition of scale. The galaxy has been moving and shaping matter for billions of years. In that vastness, a tiny comet is both inconsequential and extraordinary. We may never fully grasp its history or destiny, yet our brief observation adds a new line to the story of the cosmos. Every fleeting visitor, from Atlas to Oumuamua, humbles us. It challenges the notion that humans can control or even fully comprehend cosmic events. In humility, however, there is wonder and an invitation to keep watching, learning, and marveling. Why these discoveries spark wonder and imagination. At first glance, a comet is just ice and rock, but Atlas sparks something deeper. A sense of awe, of possibility. It invites imagination to stretch across light years, envisioning distant suns, unknown planets, and the hidden structures of alien systems. Each discovery is both scientific and poetic, grounding us in evidence while elevating our thoughts beyond Earth. Wonder is essential. It fuels curiosity, inspires exploration, and reminds us that science is not merely about answers, but also about the questions that drive us. Atlas, appearing as a small point of light, teaches humility, sparks speculation, and awakens the imagination. It is a fleeting spark in the night, yet its impact reverberates in our minds. Through these visitors, we are reminded that the cosmos is not static. It is dynamic, interconnected, and full of surprises, an endless source of stories, knowledge, and beauty waiting to be discovered. How interstellar objects remind us of our small place. Think about this. Atlas is tiny compared to the vast distances it has traveled, and fleeting compared to the timescales of the galaxy. Yet its presence is visible to us, briefly intersecting with our perspective. It is a reminder that humans, despite our curiosity and intellect, occupy a tiny corner of a vast, restless universe. Such reminders are humbling, but also grounding. They teach us to measure significance, not by scale alone, but by connection. Though small, Atlas intersects our solar system, allowing observation, study, and reflection. In doing so, it underscores how our perspective is limited, yet capable of understanding glimpses of something far larger than ourselves. In this sense, every interstellar visitor is a mirror, reflecting our place in the cosmos, inviting both humility and awe, and encouraging us to continue exploring with both rigor and imagination. Here's something quietly beautiful. Atlas's path across the sky is a poem written in motion. Each arc, each fragmenting tale, each interaction with sunlight is a stanza in a story, billions of years in the making. Though science measures its speed, trajectory, and composition, poetry captures its essence, the wonder of a tiny fragment traveling between stars, carrying with it the history of a distant system. The comet's journey is at once solitary and universal. Solitary, because it drifts alone through the void. Universal, because its materials, forged in another star system, resonate with processes familiar to our own cosmic neighborhood. It is a traveler, bridging the local and the distant, the ephemeral and the eternal. Watching Atlas, we are witnesses to a quiet epic. Its journey reminds us that even the smallest wanderer can inspire reflection, connecting human imagination with the grand, ongoing story of the galaxy. Why we may never know its true origin. At first glance, it seems possible to trace a comet back to its home star, yet 3I Atlas reminds us of the galaxy's vastness and complexity. Light years stretch between stars, and gravitational nudges from countless bodies subtly alter paths over millions of years. Even precise measurements today may never reveal the exact system that birthed it. This uncertainty is not failure. It is a window into the scale of the cosmos. Atlas is a reminder that some mysteries are inherently beyond reach. Its journey is shaped by innumerable encounters, chance events, and subtle forces that we cannot reconstruct perfectly. Yet even without a definitive origin, it teaches us about the processes of ejection, survival, and interstellar travel. Accepting this unknowability encourages a different kind of wonder, one that embraces ambiguity, honors curiosity, and finds meaning not only in answers, but in the questions themselves. The universe, in its grandeur, allows moments of insight, even amid permanent mystery, the inevitability of cosmic mystery. Here's something quietly humbling. The cosmos is vast, dynamic, and infinitely intricate, and some of its secrets will remain forever beyond our grasp. Interstellar objects like Atlas carry traces of their origins, yet they are fleeting, their paths complex, and their histories obscured by distance and time. Mystery is not a flaw in our understanding, but a fundamental feature of the universe. It invites patience, reflection, and imagination. As we study Atlas, we confront the limits of observation, measurement, and human perspective. And yet, in recognizing these limits, we also deepen our appreciation for the universe's richness and complexity. Cosmic mystery is inevitable because the scale and diversity of space exceed what any single civilization or even 1,000 generations of observers can fully grasp. Atlas is a symbol of this inevitability, a traveler whose story is partly known and partly unknowable, inspiring humility and wonder in equal measure, accepting the limits of human knowledge. Think about this. The brief appearance of an interstellar visitor like Atlas confronts us with a profound truth. We are observers in a universe far larger than our ability to comprehend fully. Even with advanced telescopes, computational modeling, and careful analysis, we cannot follow its complete journey or see the world from which it came. Acceptance of these limits is not defeat. It is a recognition of scale and context. By acknowledging what we cannot know, we focus more keenly on what we can measure: velocity, trajectory, composition, tail behavior. In doing so, we extract lessons and insights from fleeting encounters while preserving space for wonder and imagination. Atlas teaches patience, curiosity, and humility. It reminds us that science is a dialogue between observation and mystery, and that even a brief visitor can expand our understanding in ways far beyond its physical presence. Why each visitor is a gift of perspective. Here's something quietly beautiful. Interstellar objects like Atlas are gifts, not in their utility, but in the perspective they offer. They remind us of the vastness of space, the dynamics of distant systems, and the interconnectedness of stars and planets across light years. Each visitor arrives briefly, offering insight into processes we cannot otherwise observe, and then continues onward, leaving us with questions and awe. Perspective comes not only from their size or distance, but from their very motion, reminding us that our solar system is but a small waypoint in a galaxy of endless motion. They challenge our assumptions, expand our understanding, and humble us in the face of immense cosmic scales. In observing Atlas, we glimpse our place in the galaxy. We see that while our lives are short and our reach limited, we are capable of curiosity and study, able to perceive traces of a distant world and marvel at its journey, the endless sky, and the secrets it still holds. At first glance, the night sky may seem static, serene, and unchanging. Yet every moment, objects drift, stars evolve, and cosmic travelers like Atlas pass unseen. The universe is restless, full of motion and potential. Its secrets are vast, some revealed, many hidden, waiting for instruments, patience, and insight to uncover them. 3i Atlas is a small part of this larger story, a reminder that the sky is not only a backdrop, but an archive of the universe's activity. Each comet, asteroid, and planetesimal carries fragments of history across light years, connecting distant times and places to our own observation. The sky is endless, and within it lie countless mysteries waiting to inspire curiosity, scientific inquiry, and quiet wonder. In this way, Atlas exemplifies both the known and the unknowable. It is a fleeting messenger, a teacher, and a muse, reminding us that the cosmos is alive with stories we may glimpse but never fully grasp. A vast, infinite library in which we are privileged, if brief, readers.